day, future engineers. I'm Engineer Dario Tacobanza, and today we will talk about calculator techniques that you can use to solve engineering problems. Electrical motors made transportation and logistics more efficient and possible across land, air, and sea. In the given problem, we will use a calculator technique to solve a related rates scenario. Allow me to read the given question. A steel bridge is 10 meters above the water and a ship is passing at 3 meters per second speed under the center of the bridge. At the same distance, the woman is walking along the bridge 2 meters per second, reaches the same point. How rapidly are they separating 3 seconds later? As you can observe, this is a three-dimensional scenario where you have x, y, and z respectively. X represents the distance between the bridge and the ship, then the center of the bridge as its elevation given the y distance, and z for the distance of the woman and the ship. On the next slide, you will see the choices on the given problem. Since we have this three-dimensional scenario, let's take a look on the next slide to give you an idea on how to derive on our working equation. We can come up with two equations with three unknowns on this given scenario. Y squared is equal to 10 squared plus 3t squared, which represents the Pythagorean relationship between the bridge, the speed of the boat, and given y squared. Z squared represents the distance between, or the rate of, the woman walking along the bridge with its respective distances. We can observe in these two equations that it has the same variable y squared. So on our third equation, that will be our working equation that can be input in our calculator later on. So that will be z is equal to square root of 10 squared plus 3t squared, which represent the speed of the boat, and 2t squared that will represent the speed of the walking woman. Let's now use our calculators to solve this problem. In the normal setting, let's call the derivative function, then input the working equation. So that is 10 squared plus 3t squared, but this time we will use x as our working variable. 3x squared, then 2x squared. So now the equation is ready. The only missing data is the limit or the value of x that this approaches. As we review the problem, it is asked how rapidly are they separating 3 seconds later. So this 3 seconds is our approaching value for x. So let's input 3. Now the equation is ready. For our derivative, let's press equal sign. So on your screen, you will see that the answer is letter A. And that's it. As a review, in a normal setting of our calculator, we can use derivatives to solve related rates problem. Thank you for listening, future engineers. I hope that you learned something about calculator techniques that you can use for solving engineering problems. See you on the next video.